Hello and welcome to the Section 3.1 lecture. Today we're going to take a look at starting our equation solving for Algebra 1 Part 1. A big part of math is obviously equations. We've been dealing with expressions so far, and now we're looking at equations. So an equation is a mathematical sentence. So I'm going to say math sentence with unknown quantities, with unknown, I'm gonna go ahead and say unknown variables. Okay, a solution to an equation is a value for the variable. Okay, it's a value for the variable that we don't know. Inverse operations are what we use to solve equations. And the easiest way to visualize that is if I look for an operation, every single operation that we have has an inverse. Sorry, I can't write that very well. But every operation has its inverse, or the thing that undoes that operation. So operations for us are add, subtract, multiply, and divide. Okay, those are our basic operations. We have other operations that sort of expand on these, but we're going to mainly focus on these four. So the way I undo addition is to subtract. The way I undo subtraction is to add. I undo multiplication with division, and I undo division with multiplication. So we see some kind of parity between those, that I have pairs of operations that go together. For the properties of equality, instead of defining all these, I want to kind of group them together, okay, and really say for all of these that I can do the same thing to both sides of an equation. Okay, I can do the same thing to both sides of an equation. So if I have something like A equals B, I can add a number to both sides, I can subtract a number from both sides, I can multiply both sides by a number, and I can divide both sides by a number, and it's still the same thing. It's still equal. Okay, A would still equal B. Okay, and that's kind of hard to see until we get some experience with that. So how are we going to solve equations? We are going to use inverse operations and these properties of equality. So properties of equality, which really just means properties of equations. So properties of equality to get the variable by itself. By itself. Okay. Now we're going to take our time through this, but we're going to jump right into some examples here. All right. So every time that I look at an equation, I think to myself, what's happening to the variable? Okay. When I look at this first one, x is being added by 7. Okay. 7 is being added to x. So in the long scheme of things, and we don't typically write it this way, but using the properties of equality, specifically the subtraction property of equality, if x plus 7 equals 16, I can subtract 7 on both sides, and everything's still the same. Now, what weight does that carry? What does that do? Well, now I have like terms over here and over here, right? We've dealt with combining like terms. These are like terms, and they actually get us to kind of x plus 0, but I don't have to write an x plus 0. Okay, so basically what I did on this left side is the 7s are going to cancel out. Okay, and over here, my like terms, my 16 minus 7, that's going to give me 9. So I'm going to get x equals 9. Now, I said that we don't usually write it this way, and that's because we don't, because it's a lot more writing. Okay, that's the main reason. What I do instead is I say that I'm going to subtract 7 from both sides. And then when I subtract 7, those go away, and this gives me a more common look of subtraction. But we get that x equals 9. Now, why I wrote that so spread out, I'll never know. Okay, we get x equals 9, and we're done. That's all. We wanted to find a solution. We wanted to find a value for the variable, and we've done that. Okay, on the next one, what is happening to x? And I want to undo that thing. X is being multiplied by 5. I undo multiplication with division. So I'm going to divide both sides by 5. Now, another way to write this, and again, we don't typically write this, is 5 divided by 5 times x. Well, 5 divided by 5, that's ridiculous to write. That's just 1. Okay, that is 1. And even writing 1x is ridiculous because I don't have to write it. So now I have x by itself. In practice, what we do is we cancel out those 5s on the top and bottom. Okay, so now I have x equals negative 35 divided by 5, which is negative 7. And I'm done. So we kind of get the sense that every problem, we're trying to turn it into 1 times x plus 0 equals some number. Okay, equals something over here. Because the 1 times x doesn't change x at all, and adding 0 to x doesn't change it at all. So I'm trying to get to this. This is my goal. Okay, this is what I'm trying to get to. And I want some number over here, like 82, just some random number. It's not completely random because it's going to be the answer to our equation. Okay, on the next one, what is happening to that x? Well, x is being subtracted by 2. I undo subtraction with addition. I want to add 2 to both sides. Okay, I'll add 2 to both sides. Over here, we say they cancel out because negative 2 plus 2 is like x plus 0. So I have x is now equal to negative 3 plus 2. Negative 3 plus 2 is going to equal negative 1. Okay, again, those are kind of like terms. I have a negative 3 and a positive 2. Slam them together just like what we've been talking about. But that's the only thing over here. Okay, so now it's like we have expressions like we've been dealing with combining like terms, distributive property, all those things. But now we have two different sides of that expression. We have the left side expression and the right side expression. We're trying to get one side to be just the variable and the other side to be just a number. Okay. Next one, negative 8 times x equals 48. So x is being multiplied by negative 8. I want to undo that with division. I want to divide negative 8. Divide negative 8. Okay. The negative 8's cancel. And so in essence, I'm peeling that negative 8 off of the x. So now I'm going to have x is equal to 48 divided by negative 8 is negative 6. Okay, and that problem's done. And I could always go back and check it by putting this value for x in for x in this equation before I canceled it out, okay, I can test it. I can say, well, what is negative 8 times negative 6? Negative times a negative is a positive, and 8 times 6 is 48, which is what this is. So negative 6 is in fact the answer. Okay, let's look at the next one. X divided by 4 is equal to negative 5. Okay, how do I undo dividing by 4? With multiplication. So I'm multiplying by 4 on both sides. That's the multiplication property of equality, that I can do the same thing to both sides. And when I multiply by 4, when I multiply through this, 4 times x is 4x, and we can think of this as 4 over 1. So now it's like we're multiplying fractions. Okay, 4 times x is 4x. 1 times 4 is 4. And 4 divided by 4, we canceled those out earlier. We might as well do it here. So x is going to be equal to negative 5 times 4, which is negative 20. So just to write it a little bit better, x is equal to negative 20. And we're done. Once we get the variable all by itself on one side, that's when we know we're done. Okay, this last one here, x divided by 3. I want to undo dividing by 3. I'll use multiplication. In practice, we're just going to say that those 3's cancel. But since I multiplied by 3 on the left, I have to multiply by 3 on the right to keep everything balanced. Every equation is this, it starts as this balanced scale. And when we do something to one side, we've got to do that same thing to the other side to keep everything balanced. Okay? So here we're going to get x is equal to 16 times 3. You know, if you have to use a calculator, go ahead. But 6 times 3 is 18. 3 times 1 is 3, plus 1 is 4. So we get 48. Okay. Let's look at this application type problem. It says an American flag has an area equal to 9.5 square feet, while its length is equal to 1.9 feet. We want to find the width. Okay. For this problem, just so that it makes sense being a flag, and I laugh about it because I know something weird that's going to happen. I'm going to call this my length. I'm going to think of it as this is my length and this is my width. Okay. Kind of backwards typically on rectangles, but that's okay. Just so it makes sense, or just so it looks good. All right, we know that the length is not L, it's actually 1.9. And we want to know how wide it is if the area is equal to 9.5. Well, we have to think, what is area of a rectangle? Area of a rectangle is length times width. Okay, well, if my area is 9.5 and my length is 1.9, I'm trying to find my width. Well, 1.9 is being multiplied by W, so I can undo that multiplication with division, divide by 1.9, cancel out the 1.9s, and W is going to be equal to, a calculator might be helpful on this. Let's bring one over. 9.5 divided by 1.9, and we get 5. Okay, so that flag, to keep its, its right dimensions, would be 5 feet this way, 1.9 feet this way. So kind of like maybe a big flag in a classroom. It's actually kind of big if it's 5 feet that way. All right. So anyways, good luck. Make sure you take a look at these problems and a quick look at the problems that we're going to go over in class. Give some of those a shot. Write down any questions you have on the left. Have a great day, and we'll see you in class.